Yes, class. Am I audible to all of you? Now see the last portion. Who is the Safiya Sheikh? Is it Sabiha? Zainab, Shaima, Jasleen, Hashid, Jovita. My Now is it audible? Now it's better. Hashid, I've changed the internet connection. Just let me know if it's troubling now. See, now we are in the last portion of the chapter. Let us just complete these two topics, relative velocity, because I have heard from 26th you all, some of you, screen is lagging. I have not written anything on the screen. Screen is sharing, no? Okay, okay. Physics exam is on Sunday, 2nd June. Okay. See, relative velocity in graph, let us complete so that we can start with vectors. It will also take a lot of time for the completion. Now, look, when we are talking about relative velocity, velocity we have studied, everything about velocity we have studied. Now, relative velocity means when two bodies are moving. See, we have studied that in kinematics, we have the concept of relativeness and absolute cases. So when a body was moving, its velocity, acceleration, displacement, everything we have calculated, and that was just this absolute velocity of the body. Okay. Now, if one more body is moving, so there would be a change in both the body's perspective because of the frame of reference. If the person is observing from the ground, the velocity would be something else. If both the persons are sitting within the car, the velocity would be something else. That is the concept of relative velocity. See, understand it in this manner. Suppose there is a car. I'll repeat, Zainab. See, relative velocity basically means velocity between two objects. Whenever you have the term relative, it means with respect to something. You are comparing it with something. That is your relative velocity. Suppose there is one car. This is A. And there is one more car, B. When I say velocity of car A is 5 meter per second, that means it's the absolute velocity, just the sole velocity of the car. Means if a person is standing on the ground and observing the car, then we say that velocity for the car is 5 meter per second. If I just say velocity of car A is 5 meter per second, this means that if a person is standing on the ground and observing these two, then the velocity of car A is 5 meter per second. And let's assume velocity of car B is 6 meter per second. This is something with respect to the ground. With respect to the ground. With respect to the ground means observer on ground. If I am standing on ground, I am static, I am stationary, and I am seeing car A move. So for me, car A would appear to move with 5 meter per second. That is the absolute velocity with respect to ground. Similarly, B is also with respect to the ground. Now see, but this was with respect to the person on ground. But if a person is sitting in car B and a person is sitting in car A, one person is sitting in car B. When they look at each other, because this is also moving with some speed, this is also moving with some speed. So there is a relativeness when they are moving because they are not stationary. So they'll not see the actual velocity. So there would be a different velocity, that is VAB, that is velocity of A with respect to B. or VBA, velocity of V with respect to B. This is what we obtain. VAB is velocity of A with respect to B when observer is in B, and VBA is velocity of V with respect to A. When will I use VAB? I'll use VAB when my observer is in car B and we are calculating the velocity of A. Okay. Calculation of velocity of this car A with respect to the observer in B. That's why VAB. If this is the case, person A, one person is there and another person is here in B. Nobody is there in B. The person A is there. Person is in the car A. So we are calculating velocity of B with respect to A. With respect to A, where I am sitting, like this. Okay, so VBA. Just understand these terms because calculation part is very easy. Relative velocity in one dimension. You have relative velocity in two dimensions in your projectile motion. Now look, when we say VAB, that means velocity of car A minus velocity of car B. What is VA? VA is velocity of A with respect to ground. What is VB? Velocity of B with respect to ground. If you are calculating VBA, that means VB minus VA. That is VB minus VA. So you have to be careful what is the thing that you are calculating. These are with respect to ground. This is the relative part. Okay, class, this velocity, this is the relative velocity. These two. And these are with respect to ground. That means these are absolute. These are absolute, actual velocity of the vehicles. This is a short topic, easy topic. Sign conventions. Sign conventions are easy. I'll tell you. Nothing is there in a difficult portion. Just write down from here. Relative velocity. I'll discuss it then. The sign conventions. Then straight away we'll come to the questions because here nothing new is different. You just have to subtract in one dimension. VAB, VA minus VB, VB minus VA. So sometimes VA would be missing, sometimes VBA would be missing. It's just that you have to understand which term. Because in the question VAB, VBA, this won't be asked to you. Calculate velocity of car A with respect to B. Calculate the velocity of car A with respect to a person standing on ground. So that be very clear with the terms. If you have still not understood any of the terms, let me know. I'm here. Start writing. Let me know if any doubt you have.
Can you scroll a little bit up?
Done, class?
No, ma'am.
Yes, class. Now let us discuss the sign convention. One more instruction, class. Please open up your cameras. In the last class also, I have told you. This is not an instruction from my side. Okay, this is instruction from the Learnivio team itself. Okay. So otherwise, the message will be sent to your parents. So please abide by the rules. And it's the meeting. The meeting is already on the focus mode. So nobody is going to see you except the host. All right. Now, see the sign conventions. When we are talking about the sign conventions, how to follow the sign conventions here? See, class, again, the way we have discussed motion under gravity. When we were discussing motion under gravity, what did we see? We had studied that one direction we'll take it as positive, one direction we'll take it as negative, right? That is what we have chosen. One direction would be taken as positive, one would be negative. If we choose the above direction, that is up as positive, anything that is going up, whether the displacement of the ball, whether the initial velocity, we used to consider it as positive. If anything is coming down, if I have taken it as negative, so if acceleration due to gravity was negative, I'll take it as negative. Okay, Shaima. So in such cases, especially for relative velocity in 1D, follow the same thing. Take one direction as positive, take another direction as negative. Similarly to what you've studied in motion under gravity. Okay, so you have suppose right side, a car is moving. Let me give you this example. A car is present. Okay, this is car A, this is car B. Now the velocity of car A is, let's say, 12 meter per second. And let's say velocity of car B, this is 2 meter per second. Both the cars are moving, suppose, or let's say this is moving in this direction, this is moving towards the left. So this is our right side. This is our right side and this is our left side. Now look class, suppose I'm saying randomly you have to choose. You have two directions, you have one left and you have right. Suppose I take left as positive and I'm taking right as negative. This is my sign convention. So I have to state this, that yes, I am taking left as positive and right negative. If you are, suppose you were answering this question, suppose any of you were answering and you wanted to take left as negative. So it's your sign convention. You will mention that left is positive or negative, because the answer that at the end we'll be getting, that answer has to match with the sign convention. Now suppose the answer is left. Left or right will be fixed. There would be one magnitude that would be the same and there would be direction that would be the same. The answer would be, suppose the answer is, let's say, 10 meter per second towards the left. I'm just randomly giving you your data. 10 meter per second towards the left. So everybody would get 10 meter per second. There would be no doubt in this. For the left side, all those who have taken left as positive, they'll get their answer as plus. All those who have taken left as negative, they'll get their answer as minus. So we will be getting the same answer only. It's just that our sign conventions would be different. That would be changing. So suppose here I have to calculate the relative velocity of A with respect to B. Suppose this is the question. So VAB would be VA velocity of A minus velocity of B. Now look, I have to take left as positive. So this would be positive. And right as negative, this would be negative. Now let me place. What is VA? VA is minus 12. This is minus 12. Minus. What is VB? VB is plus 2. So I'm getting minus 14 meter per second. Means 14 should be common for everyone. 14 I should get even if I change this. Minus sign is showing that right side, that the net velocity will be towards the right side. Let's change. Suppose this question was solved by somebody else and the student has taken left as negative. I actually taken it as positive. So किसी ने left को negative लिया है. Left as negative and right as positive. Now what would have been my answer? Now look, VA is towards the right. So it would be plus 12 meter per second. And VB, this is towards the left. So this would have been minus 2 meter per second. Okay. 2 meter plus 12 meter per second minus 2 meter per second. This is now my answer that I'm getting. Now see, when we are talking about the relative velocity, I have to calculate VAB. That is VA minus VB only. What is VA? VA is 12. Then we have this minus sign. What is VB? Minus 2. Can you see again? This is 12 plus 2, which is equal to 14 meter per second. And I'm getting a positive answer. What is my positive this time? My positive this time is showing that direction is towards the right. Right 14 meter per second. Here negative sign was also showing right side, right with 14 meter per second. So see, this is how you will choose the sign convention and you will be following the rules. We'll start with this question. Here in this question, I've specified the direction because this was the first question. Then later, we won't be specifying any direction. Okay. Write this down first from here. Try this question, class. Tell me your answers. Class, this sign convention I have just written for the uniformity of the answers. You can change this. You can make up as negative, down as positive. It's just that you will tell me the magnitude with respect to north or south or whatever is the direction coming. At least tell the answers of these first two parts. These are very easy. Just subtraction. Mention the direction also. All those who have answered, mention the direction, north or south. Just mention N or S, so that would complete your answer. Magnitude is right. Okay. See, first answer, velocity of train A with respect to B. Look class, VA minus VB. Now, when we are discussing this VA minus VB, C class, velocity, this I had told you that what is the sign convention that we had chosen, right? So we have chosen the sign convention, this. Up is positive and down is negative. So if up is positive, this becomes 30 and this becomes minus 50. So the answer for the first two parts is Jesleen also. Yes, correct. Good. Very good. So Jesleen, Zainab, and Shaima. Good answers. VA minus VB, 30 minus 50. So that would add and make it 80 kilometers per hour. And when it's the other way around, that is VB minus VA, minus 50 minus 30, it's minus 80 kilometer hour per hour downwards. Means this is showing you north side and this is showing you towards south. Last part says that a monkey is running on the roof of train A with velocity 5 kilometer per hour. With respect to passenger A, you have to calculate the velocity of monkey. What is this velocity 5 kilometer per hour? Velocity of the monkey means the individual velocity. That is the velocity of monkey with respect to a person who is standing on the ground. Vm you have to calculate. But what are the other things that are mentioned? What exactly is this 5 kilometer per hour? So look, when we are talking about VMA, this is 5 kilometers per hour. Okay. VA is 30 kilometers per hour. What is VMA? Velocity of monkey with respect to A. How can we say this? This is given in the question. This is given in the question itself. What is VA? Velocity of the train A. That is also mentioned in the figure, right? This is already mentioned in the figure. That is 30 kilometers per hour. So VMA is 5 kilometers per hour. VA is 30 kilometers per hour. We know VMA is VM minus VA, right? VMA is VM minus VA. Fine. VMA is 5. VM we have to calculate. What is VA? VA is 30, which is given. So from here, VM will be equal to VMA plus VA. That becomes 30 plus 5, which is 35 kilometers per hour. This should be clear. By C, you had three things. You had VMA to calculate. Okay. VMA was VM minus VA. VA we know from the question itself. Okay, class? VM was to be calculated by you. That was the question. Calculate velocity of the monkey. VM is the velocity of monkey with respect to ground. What is VMA? VMA is also given in the question as 5 kilometer per hour. How do we know this? Because it is mentioned here with respect to passenger A. That means with respect to a person sitting in train A is the velocity of the train with respect to A. So is the third part also clear to all of you? This part? Yes, no, what? Others also? Just give a thumbs up. It's okay.
Yes, ma'am.
Okay. Write down the solution. Question you have written. Third part also you have write down the question. Complete this. Okay, Jobita. See, class, this is a very short question. A jet is moving upwards with a velocity of 450 km per hour. It ejects the exhaust in the opposite direction here, the fuel, fire, and everything, which is 1200 kilometers per hour. With respect to the jet, okay, you have to find out the velocity of this. See, what is 450? 450 is the velocity of the jet. Vj is given as 450 kilometers per hour. The exhaust, this 1200 is with respect to jet, means velocity of the exhaust with respect to jet is given as 1200 kilometer per hour. You have to tell what is the velocity of this exhaust. Fine. So again, let us choose one direction as positive, other as negative. Let's choose up as negative and downwards as positive. Firstly, sign convention is very important in relative velocity. And class, I was checking, nobody has submitted the last homework. You have not submitted the homework, or have you? Just inform me so that I can confirm. I have received Shaima's and one or two students dimensional analysis homework only. Where are the homeworks of motion in a straight line? Please let me know if you've submitted or not. You didn't submit. Okay, Harshit. If anyone has submitted, because I was checking, see, I have received Sabiha, Muniba, Jasleen, Shaima. Their dimensional differentiation integration was also submitted, but motion in a straight line was not submitted. Please submit the homeworks. How will I discuss the answers then? So see, VEJ. VEJ means VE minus Vj. What is Vej? Or let's see, Ve would be then Vej plus Vj, right? So what is Vej? Velocity, this is 1200, right? Lots of work recently from school plus exam. Okay, at least attempt it, Hashid, whatever, how much you are able to do, just let me know. Okay, there was an issue in the app, Zainab. Now is it working? Check and let me know if there's an issue particularly in your portal, or if anyone else is also facing this issue of assessment or the homework. Let me know. Zainab, this is it's working properly now, or is there any issue? Other students
It's
also, let me
okay.
know. Harshit, try to at least submit one or two questions at least. Easy question. I give very less homework. 1 or 2 questions are there. So try it at least this week. I can understand what you have not submitted, but now onwards, whatever questions will be given. Today, I'll give the questions of relative velocity. Tomorrow, we'll discuss them. So please submit it, class. Okay, tomorrow I'll discuss them. 1200, this is 1200. Then we have plus, what is Vj? This is minus 450. It's working. Okay. No, Jasleen, that is negative. So it would be 750. We'll subtract, no, 12, and this is minus. So it would be 750 kilometer per hour. And it's coming positive. And it has to be, see, the exhaust will definitely be downwards. And we have taken downwards as negative. So this is satisfying with our answer. 750 kilometer per hour downwards. Okay, write this down quickly. One very small question we'll see. Then, or we'll start with the graph part. This question we can come later on. Okay, just write down this. We'll see the graph part first because some of you are having exams tomorrow and day after tomorrow. So at least let us do the graph part. And you know the basics of relative velocity now. More practicing of questions, we can do it later. Graph part, at least it is complete. So we are through with the chapter. Write it down. I'll start with the graph. Next, done class once written till here. Others also have completed. Now, see, graph is what? Graph is basically pictorial representation of a function. So there are different types of graph, you know. So firstly, you have the straight line graph. What is this? This is a straight line graph. And when do you use a straight line graph? When your y-axis component is directly proportional to x component with the power 1. Okay, so this is how you will be calculating. One axis will be representing one quantity, other axis will be representing another quantity. And then you will see their relation. If this is a graph, it will show that both are proportional to each other. So this is how, by just looking at the graph, you can predict on things. Now see, there is this angle that the inclination is making. When you take tan theta of this angle, that gives you the slope. The slope is given by tan theta. For example, if I tell you this is a graph between distance and time, sorry, displacement and time. Okay, on the, let's say, y-axis we have displacement, and here we have time, and we are getting a straight line graph. So when we divided x divided by t, that gives you velocity. Or velocity can be calculated directly by tan theta, because this is the slope. So understand this, whenever two things are getting divided, the third quantity is given by the, is telling you the slope. Here, this velocity is the slope. Whenever you have to calculate the slope, just divide. Okay, whenever you have to calculate the slope, just divide y and x. That will give you your major portion of the answer. Now we have different types of graph present. There are different types of slope only. There's a positive slope. Positive slope means when the angle is more than 90 degree. Angle is less than 90 degree. That is, you are getting an acute angle. So if your theta is acute, what will happen? Tan theta will be positive. So your slope will automatically become positive. That's why we call this as positive slope. Like these kinds of graphs which you see, where this angle is very less. These angles are less than 90 degrees. If this angle becomes more than 90 degree, then that we call it as the obtuse. So now here we'll be getting this. This is also a straight line graph only. These are types of straight line graph only. These are straight line graphs only. So negative slope means the angle is more than 90 degree, but less than 180. This also has to be a condition, means we call this condition as obtuse angle. Okay. Now there is zero slope also. One is positive, other is negative, third is zero slope. Zero slope means, see, 0 degree means with respect to x-axis. Means if you have this with respect to the x-axis. Look, this is 0. They are parallel. What is the angle this line is making with x-axis? Nothing. They are parallel, 0 degree. So tan theta is 0. So your slope will also be 0. So this also we call it as a straight line graph. See, because we are getting a straight line. But with a zero slope or a positive slope or a negative slope, that will define whether which type of straight line this is. Okay. Write it down till here. These are just from the scratch, from the very basics of graph we are starting. We'll come to our topic also, but these are very basics of the graph that you already have studied in your basic classes. Write it down, keep on updating me in the chat column. Class done, written, need more time and all. Done? Yes. Okay, complete it. Okay, class. Now, there are two more types of slopes depending upon your variable and your constants. If the quantity is varying, then you cannot have a straight line graphs like this, the way we were having straight line graphs. See, at every point it is increasing, but the values are remaining constant. So if you have a, see, two types of graphs are there, constant slope and variable slope. For slope, we use the symbol M. So wherever you see M, that means slope. And for the y-intercept, we use the symbol C. This is usually which is follow. So for a constant slope, look, this is a straight line graph, the way you were getting a constant slope. Means here, whatever is the angle theta A, it is equal to theta B, it is equal to theta C. Means your slope of A, this is actually equal to the slope of B, which is equal to the slope of C. All these are the same. So you get a constant slope graph, which we have studied above. But there are graphs which can vary also. It means if the angles are differing, like look here. This is an increasing graph. Look, angle theta A is very less, theta B is greater, theta C. How to check these angles? Just draw an imaginary or a dotted line parallel to x-axis to check these angles. Here also we'll draw these angles. Look, theta A, then theta B, then theta C. Theta C is the maximum. So you will see the order of the slope also. MC is greater than MB, it's greater than ME. Means this is the least slope. So this is an increasing slope. Here this is decreasing. Look, theta A was the maximum. Theta B, then theta C is very, very less. So slopes order has also reversed here. Write down this portion as well. Types of slope. This is also a continuation of the above part only. Write it. Class, I will continue the rest. A small portion of graphs is left, and that question that I had shown you, that I'll complete it